Pydantic AI extends agent capabilities by injecting custom dependencies through the RunContext object, allowing the model to execute external functions via the @agent tool decorator and self-correct its responses using an @agent output validator that can trigger a model retry upon failure. Initializing the agent with a specific deps type will establish a type-safe container for an asynchronous HTTP client and API key, enabling the subsequent injection of these resources into the system prompt, tool, and output validation coroutines. From data classes, import data class. Import HTTPX. From Pydantic AI import agent, ModelRetry, RunContext. @data class. Class mydeps. API key, SDR. HTTP client, HTTPX, async client. Agent equals agent. OpenAI, GPT-5.2. Deps type equals mydeps. @agent system prompt. Async def get system prompt dex. RunContext mydeps, SDR. Response equals await CTX. Deps, HTTP client, get //example, response raise for status. Return f prompt, response text. @agent tool #1. Async def get joke material text. RunContext mydeps, subject. SDR. Response equals await CTX. Deps, HTTP client, get. HTTPS, //example, #jokes. Params equals subject. Headers equals authorization. fbearer CTX, deps, API key. Response raise for status. Return response text. @agent, output validator #2. Async def validate output text. RunContext mydeps, output, SDR. Response equals await CTX. Deps, HTTP client, host. HTTPS, //example, #validate. Headers equals authorization. fbearer CTX, deps, API key. Params equals query, output. If response status code equals 400. Raise model retrieve invalid response text. Response raise for status. Return output. Async def main. Async with HTTPX. Async client as client. Deps equals mydeps foobar, client. Result equals await agent. Run tell me a joke. Deps equals deps. Print result, output. Did you hear about the toothpaste scandal? They called it Colgate. This implementation demonstrates a robust dependency injection pattern using the agent, class, and a custom deps type. By encapsulating the HTTP client and API key within a data class, the code ensures type-safe access to external resources across the entire agent lifecycle when agent.run is executed. This approach avoids global state and makes the agent highly testable in production environments. The core mechanism relies on passing RunContext to various agent hooks. The @agent system prompt decorator uses this context to fetch dynamic instructions at runtime, while the @agent tool decorator exposes external data retrieval capabilities to the model. Both functions access the injected HTTP client through the deps attribute, ensuring all network operations share the same connection pool and authentication headers. The most critical pattern shown here is the self-correcting validation loop. The @agent output validator intercepts the model's final output and verifies it against an external endpoint. If the validation fails, raising a model retry exception halts the current completion, feeds the error message back to the model, and prompts it to generate a corrected response. This shifts error handling from the application layer directly into the LLM reasoning loop, significantly improving reliability for complex generation tasks. Let's break it down. From data classes, import data class. Import HTTPX. imports the data class decorator for defining data-centric classes and the HTTPX library for making HTTP requests.
At data class myDeps.
Defines a new class named myDeps using Python's at data class decorator. This automatically generates standard methods like initialization and representation, setting up the class to serve as a structured container for dependency data.
API key, SDR. HTTP client, HTTPX, async client.
Declares two typed attributes for a data structure or class. The API key is defined as a standard string, while HTTP client is specified as an asynchronous HTTP client using the HTTPX library.
Agent equals agent. OpenAI GPT-5.2.
Instantiates a Pydantic AI agent and assigns it to the agent variable. The constructor takes OpenAI GPT-5.2 as its first positional argument, configuring the agent to use this specific OpenAI language model.
At agent system prompt. Async def get system prompt dex. RunContext myDeps, SDR.
Registers an asynchronous function to generate a dynamic system prompt for the agent. The function accepts a RunContext parameter typed with myDeps to access runtime dependencies and is defined to return a string containing the prompt text.
Response equals await CTX. Deps HTTP client get //example com. Response raise for status. Return fprompt response text.
Executes an asynchronous HTTP GET request to HTTPS //example com using an HTTP client accessed through the agent's runtime dependencies. It validates the response by raising an exception if an HTTP error status code is returned. Finally, it extracts the text content from the response and returns it formatted as a string with a prompt. Prefix.
At agent tool #1. Async def get joke material text. RunContext myDeps subject. SDR.
Registers the asynchronous getJokeMaterial function as an agent tool using the @agentTool decorator. The function accepts a runtime context typed with myDeps dependencies alongside a string subject and returns a string result.
Response equals await CTX. Deps HTTP client get HTTPS //example com #jokes.
Executes an asynchronous HTTP GET request to the provided example URL using an HTTP client accessed through the agent's runtime dependencies. The network call is awaited, and its result is assigned to the response variable.
At agent, output validator #2. Async def validate output dex. RunContext myDeps output. SDR.
Registers an asynchronous validation function for the agent's response using the @agent output validator decorator. The function accepts a RunContext object containing dependencies of type myDeps, along with the model's generated string output. It evaluates this data and is defined to return a final validated string.
Response equals await CTX. Deps HTTP client post. HTTPS //example com #validate.
Asynchronously sends an HTTP post request to the specified URL using an HTTP client accessed through the Pydantic AI RunContext dependencies. The network operation is awaited, and its result is assigned to the response variable.
If response status code equals 400. Raise ModelRetry invalid response. Response text.
checks the HTTP response for a 400 status code. When a bad request is detected, it raises a ModelRetry exception containing the raw response text. This directly instructs the language model to retry its generation using the provided error message as feedback to correct its previous output.
Response raise for status.
Calls the raise for status method on the response object to verify the HTTP request succeeded. It automatically raises an exception if the response contains an error status code, preventing the application from silently attempting to process a failed request.
Return output.
Returns the value of the output variable to the caller, concluding the execution of the current function or method.
Async def main.
Defines an asynchronous function named main that takes no parameters. This typically serves as the primary entry point for executing asynchronous code.
Async with HTTPX. Async client as client. Deps equals my dips foobar, client.
Initializes an asynchronous HTTP client within a context manager to ensure proper resource cleanup. It then constructs a mydeps instance using a static string and the active HTTP client, assigning the result to the deps variable to serve as runtime dependencies. Binding a custom data class to the agent dependency type establishes a unified, type-safe pipeline that flows from initialization through execution. The RunContext acts as the connective tissue across the entire lifecycle, carrying the shared HTTP client and API key into the system prompt, the external tool, and the output validator. The core insight is how this shared context bridges the read and validate phases of the agent. By passing the exact same client instance from the initial dynamic prompt generation all the way to the final output validation, the agent maintains a single, authenticated network session across its entire reasoning loop. When the validator catches a bad response and raises a model retry, it leverages this unbroken chain of state to feed the error directly back to the LLM. This transforms a standard application exception into an active, self-correcting generation cycle, keeping the architecture completely free of global state.
The output validator raises ModelRetry to discard the response, forcing the agent to fail into success.